terminology associated with graphing the sine function that you probably never heard of before, so we need to make sure that we have that terminology down pat. So we're going to start with just graphing the plain old sine of x, which is the very first example you have there on your paper. Let's talk about a few things. Actually, let's go ahead and get the graph down there, and then we'll talk about some more stuff. Okay, so in your calculator, number one, you need to be in radian mode. Okay, you need to be in radian mode. When you look at your graph there, it is labeled in terms of pi on the x-axis. So you need to be in radian mode, number one. You need to go to your y equals and just type in the sine of x. Okay, just type in the sine of x in your y equals. Now, based on what we have there, they gave us a graph, so we want our graph to fit in that. So before I press graph, I'm going to go to my window and I'm going to adjust it. Okay, so my x values, they don't have anything labeled on the left side of that graph, so we're just going to start at 0. Okay, and the right side, the last thing that they have labeled is 3 pi. Guess what? You can type pi in there. Okay, you can type pi in there. So 0 to 3 pi. We could change the scale. It looks like they're counting by pi over 2. So let's go ahead and change that just so that it looks the same. Okay, the y minimum, they've got -6 to +6. So let's go with those values right there. Okay, then we're going to press graph. Okay, and so here is the graph of the sine of x from 0 to 3 pi with the y values from -6 to 6. So you notice that it looks like it's starting to repeat a pattern, and it does. If we were to extend those x values a little bit further, that pattern would continue to repeat. We can even go over to the left side, but we're just going to focus on this part of the graph right now. All right, so I'm actually going to use some of the values off the unit circle as well as I graph this. So let me kind of break up my graph semi-evenly here. Pi, 2 pi, 3 pi. Y'all already got this on your paper, so you don't have to worry about it. Then we've got pi over 2, 3 pi over 2's between these. 5 pi over 2 goes right here. Okay, so the sine of 0 is 0. We can see that on the graph. It starts at the origin. It's pretty obvious there. Okay, if we go, let's say this is 1 and this is -1. Okay, the sine of pi over 2 on the unit circle is 1. Okay, so we've got a point there at pi over 2, 1. The sine of pi is 0. We can see that on the graph. We can see it on the unit circle. The sine of 3 pi over 2 is -1. The sine of 2 pi goes back to 0. If we were to continue the pattern, 5 pi over 2. 5 pi over 2 is the same as pi over 2. All right, you've just gone pi over 2 units past a whole rotation. And then 3 pi, we're back on the origin. So we're just going to connect these dots. We see on the graph on our calculator that it looks like kind of a curve. They're almost like parts of circles, almost, is what it looks like. To me, if you're a very visual person, you can kind of visualize the unit circle kind of rolling and unfolding itself, so to speak. I don't know if that makes any sense, but it's kind of what I see in my mind when I see this graph right here. It looks like a circle, and it's just kind of rolling around there. Okay, so let's talk about this term period. Okay, we talk about these are periodic functions. Your trig functions are periodic functions. It means it repeats itself every certain number of units. Well, if we look at it, we start here at the origin, we hit our maximum, we go back through the x-axis, we hit our minimum, and then we end back up where we started. And then we repeat the process. So we completed that one complete cycle in 2 pi units. So that is what is referred to as the period of a trig function. It's 2 pi. It's the length that it takes to complete one complete cycle, beginning to end, hit the max, hit the min, end up where you started. Okay, so the period or the cycle length of this is 2 pi. That's the standard. Okay. Another term that you may see is the term midline. Okay, the midline is right in the middle of our function. It slices our function right in half. So in this case, the standard midline is y equals 0. It is the x-axis. Okay, y equals 0, or the x-axis is what we consider the midline. It's right in the middle of that function. Okay, and then in conjunction with the midline, we also talk about something called the amplitude. Okay, the amplitude, the definition of the amplitude is it's the distance from the midline to the max or to the min. So we start on the midline and we look at, well, how tall is it? Or we start at the midline and we say, how far below the midline does it go? So the standard amplitude for your sine of x function is 1. Okay, from the middle to the top, that's 1 unit. Or from the middle to the minimum is 1 unit. Okay, so these are the standards. We're going to look at changing those, translating this function. So these 3 things, some of them will change in one scenario, some of them will change in another scenario, but we're going to look at how those change. But these are the standards. The period is 2 pi, the midline is the x-axis, or y equals 0, and the amplitude is 1. Now, I'm going to kind of step away from the graphs you have there on your paper. I kind of just want you to watch for a little while, and then I'm going to let you practice with the ones that are there on the paper. All right. So what if we stick a -3 in front of this sine of x function? Okay. What if we stick a -3 in front of the sine of x function? So what I have up here on the board right now is I've got just the regular old sine of x because I want to compare the two. Okay, so in my calculator, I'm going to leave the sine of x in there, and in y2, I'm going to type in -3 sine of x. Okay, so I've got the original. Here comes the second one that I'm graphing. I want to compare them. So what are some things that y'all observe? What do you see?
It's going the opposite way.
Okay, it's going the opposite way. It's flipped over. What else? It has a bigger amplitude. Okay, it's stretched out. It's a little bit harder to see because it's flipped over, but yes, it is taller. It has more of an amplitude. So that's what happens right here. This number in front of the sine function is the coefficient that we call A, and it always affects the amplitude. Okay, A always affects the amplitude. That's handy because the letters match. Okay, so the amplitude is now 3. Okay, I forgot to mention this before. Amplitude is always positive. Okay, amplitude is always positive. Even if that's a negative number in front of there, the amplitude is always positive. So I'm going to put that in parentheses so I can remember that. The negative is going to flip it over. Okay, so we're still starting in the same place. If we look at the graph, we still start there at the origin. Nothing changes there. But at pi over 2, where we should be hitting our maximum, now we're going to hit our minimum, and it's even lower. It's at -3 instead of -1. At pi, we still cross the x-axis. Okay, at 3 pi over 2, instead of hitting the minimum, we're going to hit our maximum, and it's now at +3 instead of being at +1. At 2 pi, we still cross the x-axis, and then it's going to repeat itself. So this is how these two graphs compare to one another. Okay. Now, I'm doing this on purpose because I have a feeling that this is kind of how they're going to test you. Not that they're going to ask you to draw them on the same axes, but they are going to probably ask you to compare, well, what translations have occurred here? Okay, what's different between this function and just your regular parent function, sine of x. Okay, we've done this with absolute value. We've done this with the x squared, the quadratic function. Now we're just talking about it with this trig function. Okay? All right, let's see what happens when we've got a number not in front, but a number inside with the variable. This is the coefficient that we call b. This is the coefficient that we call b. So I'm going to graph these two together, and let's see if we can figure out what the difference is. Does anybody have a guess as to what this will affect? The period. Okay. It is going to affect the period because it's with the x. Think about all the other functions that we've dealt with. When we have multiplied the variable by a number, what has it done? It's affected our horizontal links in some way or another. So here we can see at the beginning it doesn't really look like there's much difference. Okay, but as we continue to go on, this second function is stretched out. Okay, the second function has stretched out. That does affect the period. Here's how we calculate the new period. It is 2 pi divided by b. Okay, the new period is 2 pi divided by b. So in this case, it's 2 pi over 3 over 4. Dylan, put your phone up. 2 pi over 3 pi over 4, or not 3 pi over 4, just 3 over 4. Okay, when we divide by a fraction, we flip and multiply. So this new period is 8 pi over 3. 8 pi over 3, which we really don't have on our graph here, but 8 pi over 3 is just a little bit short of 3 pi, because 3 pi would be 9 pi over 3. So I'm just going to kind of guesstimate it here. So I still start in the same place. I still end up on the x-axis. Halfway through is where I'm going to cross the axis again. So this looks about halfway-ish. And then, well, that's not halfway. Halfway between this part, I'm going to hit my maximum. That's still not very halfway, is it? It's a lot closer. Okay, there we go. And then halfway between these, I'm going to hit my minimum. So it really stretches out our function here. Okay, so that's one complete period of this sine function, the sine of 3/4 x. Pulls it out this way. Okay, so 2 pi divided by that number with the variable gives you the new period. All right, so we talked about the amplitude. We talked about the period. What do we have left to change?
Y-intercept.
Okay, the y-intercept, or in trig terms, that's the midline. Okay, that's the midline. So we're going to skip the letter C. There is a C in there, but that's not in our standards. We only have to worry about A, B, and D. We call this D. The number here on the end is the coefficient D. And that takes the entire function and it shifts it up or down that many units. Okay, so our midline, instead of being at y equals 0, is now going to be at y equals 2.5, or you may see that described as a vertical shift. Okay, a vertical shift. In this case, we're going up 2.5 units. So we just take the entire function and move it up 2.5 units. So we started at the origin before, so now we're going to be starting at 2.5. We had our maximum at 1 before, now our maximum is going to be at 3.5. Okay, then we're back here, then we hit our minimum. It's no longer at -1, now it's at 1.5. Okay, so this is what we're looking at here. Okay, same exact shape. Nothing's been stretched out. We're just taking the entire thing and shifting it up 2.5 units. Now I could keep going on each end, but I just want to look at the one cycle there. Okay, so the reality is most of the time you don't just have one of these happening. A lot of times we have multiple of them happening at one time. So here's just a random example because I want to pull them all in, okay? So the 2 in front, what did that affect? The amplitude. Okay, the number in front affects the amplitude. So the amplitude of this function would be 2. Okay, what does the 4 affect? The period. Okay, it's 2 pi over 4, which simplifies to pi over 2. So this one has shrunk. Okay, typically we're between 0 and 2 pi, but now this one completes an entire cycle between 0 and pi over 2. Okay, so that's kind of what we're used to. We're used to when numbers are with the variable, it's the opposite of what we would expect. We multiply by 4, we're expecting things to get bigger, right? But actually it gets smaller. Any horizontal change is always the opposite of what you expect it to be. Okay, and then that -3 is the midline or the vertical shift. So the midline is y equals -3, or if you want to describe it as a vertical shift, that would be down 3 units. Yes, sir.
So this is like the graph of the sine function, and like this is like the formula, or like the basic function of
Yes.
sine.
Yes.
So are you trying to say we also have to learn the cosine function? And
No, we're only doing sine of x is the only function that's mentioned in y'all standards. Now, we could talk about cosine and tangent. They have graphs as well, and cosine is very similar to sine, but we're only going to cover the sine function in this class. When you get to pre-calc, we'll talk about cosine and tangent.